Hello, it's Griffin, and welcome to 3.3. This is going to be about accessing and displaying motor data through Shuffleboard. First of all, we got to get Shuffleboard open, of course. So the way that we can do that is to simply type in and launch FRC driver station. If you configure driver station with us in the tutorial, Shuffleboard will come up on its own because we selected it in the settings tab as the default dashboard type. Now, if it doesn't come up on its own, let's say if you decide to close it, don't want to save its layout, you can simply search for the application and launch it. It comes pre-installed with every install of WPILib. First of all, what is this Shuffleboard? So, you see all these squares and grid, but what does it actually do? We use Shuffleboard in FRC programming for displaying information. It can have different tabs. It can store information about cameras. It has access to network table information, which some devices that you might use on your robot might communicate through. It becomes a much cleaner way of printing out large amounts of data than using system.out.println, which you might have used in Java before. Now in Shuffleboard, you might see this tab called Smart Dashboard. This is the main tab that we will use, because Shuffleboard is somewhat built off of an older application named Smart Dashboard. If we launch Smart Dashboard, it also comes pre-installed with every install of WPILib. And it's another way of displaying information, but it's a lot more rudimentary, so we choose to use Shuffleboard. Now, let's get to programming to show off some of Shuffleboard's capabilities. So here we are in the project from the end of 3.2. You can see we have our primary motor and our follower motors. We have left motor and right motor. All of our current limits are set up. And we've got these motors running at a speed of 0.5 or 50%. So let's start off to show a very basic application of Smart Dashboard. I'm sure you've done this before, but we're going to do Hello World. So for us to perform a Hello World right at the beginning of the robot code running, we want to do it in robot init. Similarly to how all the motors are set up in robot init, we can also launch a printout right on the initialization of the robot code. So right here is where naming might get a little bit confusing. We're actually going to use smart dashboard dot put string. So you might be asking, why are we using smart dashboard? Well, it's because smart dashboard automatically goes to Shuffleboard as on its main tab. Because we can display Smart Dashboard information on Shuffleboard, and Smart Dashboard functions are very easy to use, we usually use Smart Dashboard for stuff that we just want to get set up and printed pretty quickly. So I actually forgot real quick, we got to import Smart Dashboard. Quick way to do that in VS Code is to hover over it, go to this Quick Fix tab, and then click Import Smart Dashboard from edu.wpilib. There we go. So now for Smart Dashboard's putString function. The putString function takes a string as the key. That's essentially what your information box is going to be named. And then the value, that's the actual value being displayed. So what we can do for our key is name it something like first printout. And then for our value, we can put hello world. Save that. Let's run a simulation to see how that works in reality. We can run the sim GUI and the real driver station. Now let's put up our Shuffleboard. Ta-da, we got our first printout. So you see that's in this box right here. And you might think, what happens if the text starts to overflow or if you want this to be somewhere else? Well, luckily, Shuffleboard makes it easy to configure our setup. With a simple click and hold, you can drag it all around and move it into any cell that you want. Also, if you hover over any of the edges, you can extend the way that the box is shaped. For now, though, we're just going to leave this up in the corner. One important thing to note is that you can see teleoperated is actually disabled right now, and yet we still have our printout. That's because we put our printout in robot init, not inside of teleop init. Let's stop our simulation real quick by going back to our WPILib file, clicking on the little stop box. So now we talked a little bit about the difference between robot init and teleop init, how this is when the robot turns on compared to how this is when we enable in teleop. But I'm going to actually demo the difference using a smart dashboard printout. The way we're going to do this is with some iterators. So first, let's create some variables that we can iterate. First off, we're going to make a private int robot incrementor. We're going to do this at the top and set its value to 0. Right near the motors, this is important so that it can be accessed by every method within this file. Next, we're going to make its counterpart teleop incrementor. Now what we're going to do is we're going to make robot incrementor increment while the robot is on, while teleop incrementer only increment while we're in teleop mode. So for the robot incrementer, we want to put this in robot periodic. Remember, robot init only runs once at the beginning of your code startup, so the incrementer would be stuck at 1. Robot periodic, on the other hand, continuously updates while the robot is on. So we're going to put the robot incrementer here. We're going to use, again, smart dashboard dot, and now we're going to use a different function. We're going to use dot put number, because now we're putting an incrementer. Put number functions the same way with the string key, the name of the box, but this time it has a double value. So we're going to name the key robot incrementor, and then the value we're going to put is robot incrementer, and we're going to increment it by 1 every time with a postfix operator. Next up, we're going to implement our teleop incrementer. Yet again, not in teleop init, but in teleop periodic, right where we set our motor speeds. We're going to do smart dashboard dot put number. We're going to say teleop incrementer, and then increment our incrementer with a postfix operator again. Now, one quick thing to note, you might see I'm using capital letters for the key. This doesn't matter. It can be any valid string that you want. I just like using capitals. Now let's simulate our incrementers. Select our SimGUI and Real Driver Station. Now let's take a look at our Shuffleboard. You can see in the Smart Dashboard tab we have this incrementer, but which incrementer is it? Let's expand its name. So this is the robot incrementer. You can see teleop is disabled, but it's still running. This demonstrates how our robot periodic is constantly running. Now let's enable teleop. Suddenly, you'll see another box pop up. Let's move this and expand it. This is our teleop incrementer. You'll notice that if I now disable teleop, it'll freeze. Enable, disable, enable, disable. So this shows how teleop periodic only runs while teleoperator is enabled. Let's stop our simulation. So you might think that was a little bit of a waste of our time just to prove that these functions work as we expected. But this is actually crucial to notice when you decide where you're going to put your printouts. As we move on to the next topic, this becomes increasingly relevant. So next, we're going to actually get some useful motor information. Now, based on this information, where are we actually going to want to put a printout that contains motor information that can be constantly updated? We're probably not going to want to put it in one of the init tabs because that'll only run once when the robot turns on or when teleoperator is enabled in teleop init. So we're going to be in teleop periodic or robot periodic. Now what to consider is, can a motor have values while the robot is not in teleop? The answer is yes. It can have a voltage of 0 or a speed of 0 while the robot is disabled. So putting it in teleop is a little bit limiting, since that means that as soon as teleoperator is disabled, we don't get any new updates, as we saw with the teleop incrementer. So generally, you want to put any smart dashboard printouts you have inside of a periodic function that is always running. Let's put it right here. So the first piece of data we're going to get is what the motor's actual percent out is. We're going to do smart dashboard dot put number. Let's check up on what the primary motor's percent out is. So that's going to be the key, the name of the box. And the value, the numerical value, is going to be primary motor dot get. So the dot get function simply gets the current set speed between -1 and 1. Let's see what happens. Select a real driver station. And now you can see we have a new box right here. Something real quick to notice is that teleop incrementer is grayed out. This is what Shuffleboard does for boxes that were previously in use but right now aren't. A way that you can get rid of them is by selecting Shuffleboard and running Control-N on your keyboard. That resets the entire display. Let's keep our incrementer over to the side for now, and let's move our percent out over here. Now, let's enable. You can see it goes up, and here's our teleop incrementer, so we're in teleop. Now, wait a second. That only says 0.26. Didn't we command it to run at 0.5? Now, let's check. Our printout isn't wrong, is it? We're going to use the robot simulation tab. This has the most raw info from the sim. We can see that the duty cycle, which is what percent out is. So we can see that the duty cycle, it reads a similar value. Now, why would that be? So this demonstrates one of the shortcomings of sim. It won't always be entirely accurate. When I initially saw this, I was really confused, trying to figure out why this would be. I did some digging, and I found out that the reason for this is actually because of the current limit, that sim doesn't really accurately use the current limit and often makes the motor appear underpowered. Now, this is why we can't trust sim for a lot of motor data, but we can at least demo that we are receiving the percent out that the motor is currently at based on the simulation. Let's disable. You can see it falls back down to 0, teleop incrementer stops, and robot incrementer continues going. Let's stop our simulation. We're going to move on to look at another piece of data that you could get from a motor. Now remember that these values are all theoretical because the simulator can be faulty at times. With that in mind though, we're going to get what the simulator displays as the voltage of the motor. We're going to use again smart dashboard dot put number. We need a key and a value. You can see that VS Code automatically generates values that it thinks could be correct, so we'll have to change them. Let's make this key primary motor voltage. And the function we're going to call is primary motor dot get motor voltage. You can see that this gets the applied output motor voltage. So that's essentially what the motor's using. But wait, why do we have an error? You can see that put number expects a string and a double, but we're giving it a string and a status signal of double. So some motors won't actually return a double for these values, but they'll return a status signal. Now, the status signal does contain a double. So now the way that we get a double out of this is we use dot get value as double. You might be asking, why wouldn't they just return a double? Well, the reason is because a status signal object contains some extra info that can be useful. But don't worry about that for now. Let's simulate and see what we have now. Looking at Shuffleboard, we have another new box. Primary motor voltage. Let's run and see what happens. See, now we're also getting a voltage readout, which, if we check the simulation GUI, is accurate. Now, the way of displaying these numbers is good, but we can do a bit better. These boxes actually aren't restricted to just being boxes. They can be visualized in multiple different ways. If you do right-click, show as, we're right now in text view, there's several options for what we could choose. Since this is a voltage, let's try voltage view. And look. Just a simple visualization to help us recognize that this is voltage. Another very useful one is show as graph. Now the graph box has some problems with resizing. You can see you can't really resize it, can't really move it. But it makes up for that in utility. You can see that shows the time that's passed in seconds, and you can see the values here. Let's try a fresh simulation to see what this looks like. Stop the simulator. Simulate again. Let's take a look at what the graph looks like. Whoa, we can see that the motor spikes up to the percent out that we'd expect. Around 0.26 is what we were getting before. This can be useful when trying to figure out the rate at which something increases, and we'll make use of this in a later lesson a lot more. Let's disable and stop our simulator real quick. So for some final notes about Shuffleboard, what I've showed you right here, is just scratching the surface of what you can do. Like I said at the beginning, you can display camera feeds, you can show all these different graph types, and remember, we were only working within the Smart Dashboard window. Within Shuffleboard's API, you can add new tabs on code running, you can have boxes automatically resize themselves and locate, you can change colors or the ways that these numbers are displayed, you can even make custom elements that demonstrate the robot's field or how certain motors are positioned. We're going to link the docs in the description of this video for more info, and I'd highly advise that you look into them. So now you've learned the way that we do printouts in FRC. We're going to use this a lot throughout the course, and I'm sure you'll find yourself using it too when you're trying to do any debug work.